Deep learning neural networks, including large language models, can be big, very big, like hundreds of billions of parameters big, and running them at inference time is usually a very compute-intensive operation. So enter mixture of experts, which is a machine learning approach that divides an AI model into separate subnetworks, or experts. Each expert focuses on a subset of the input data, and only the relevant experts are activated for a given task, rather than using the entire network for every operation. Now, mixture of experts isn't new, not at all. It goes back to a paper published in 1991 when researchers proposed an AI system with separate networks, each specializing in different training cases, and their experiment was a hit. The model reached target accuracy in half the training cycles of a conventional model. Now, fast forward to today, and mixture of experts is making a bit of a comeback. It's kind of trendy again, and leading large language models like ones from Mistral are using it. So let's break down the mixture of experts architecture. Let's see what it's made of. Well, we have in our model an input and an output. Now, we also have a bunch of expert networks in between, and there's probably many of them. I'll just draw a few. So we'll have expert network number 1, expert network number 2, all the way through to expert network N. And these sit between the input and the output. Now, there is a thing called a gating network, and this sits between the input and the experts. Think of the gating network a bit like a traffic cop, I guess, deciding which experts should handle each subtask. So we get a request in, and the gating network will pick which experts it's going to invoke for that given input. Now, the gating network assigns weights as it goes, and with those weights, we are using the results, combining them to produce the final output. So we'll get the results back from those experts and combine them into our output here. Now, we can think of the experts as specialized subnetworks within the bigger neural network. And the gating network is acting as the coordinator, activating only the best experts for each input. So let's take a look at a real-world example using that Mistral model I mentioned earlier. That's actually called Mixtral, and the specific name is Mixtral 8x7b. It's a large language model, open source, and in this model, each layer has a total of 8 experts, and each expert consists of 7 billion parameters. That's what the 7b is, which on its own is actually quite a small model for a large language model. Now, as the model processes each token, like a word or a part of a word, a router network in each layer picks the 2 most suitable experts out of the 8, and these 2 experts do their thing, their outputs are mixed together, and the combined result moves on to the next layer. So let's take a look at some of the concepts that make up this architecture. And the first one I want to mention is called sparsity. In a sparse layer, only experts and their parameters are activated from the list of all of them. So we just select a few. And this approach cuts down on compute needs as opposed to sending the request through the whole network. And sparse layers really shine when dealing with complex high-dimensional data, like, for example, human language. So think about it. Different parts of a sentence might need different types of analysis. You might need one expert that can understand idioms, like it's raining cats and dogs, and then you might need another expert to untangle complex grammar structures. So sparse mixture of expert models are great at this because they can call in just the right experts for each part of the input, allowing for specialized processing. Now, another important concept is the concept of routing. Now, this refers to how this gating network here decides which expert to use, and there are various ways to do this, but getting it right is key. If the routing strategy is off, some experts might end up undertrained, or they might end up too specialized, which can make the whole network less effective. So here's how routing typically works. The router predicts how likely each expert is to give the best output for a given input. This prediction is based on the strength of connections between the expert and the current data. Now, Mixtral, for example, uses what is called a top K routing strategy, where K is the number of experts selected. Specifically, it uses top 2 routing, meaning it picks the best 2 out of its 8 experts for each task. Now, while this approach has its advantages, it can also lead to some challenges, and that leads us to our next concept, and that is load balancing. Now, in mixture of experts models, there's a potential issue where the gating network, it may converge to consistently activate only a few experts. And this creates a bit of a self-reinforcing cycle, because if certain experts are disproportionately selected early on, they receive more training, leading to more reliable outputs. And consequently, these experts are chosen more frequently while others remain underutilized. That's an imbalance that can result in a significant portion of the network becoming ineffective, essentially turning into computational overhead. Now, to solve this, researchers developed a technique specifically for top K, and it's called noisy top K gating. And using noisy top K gating introduces Gaussian noise to the probability values predicted for each expert during the selection process. The controlled randomness promotes a more evenly distributed activation of experts. So, mixture of experts offers a bunch of advantages in efficiency and performance, but it's not without its challenges. It introduces model complexity, which can make training more difficult and time-consuming. The routing mechanism, while powerful, adds another layer of intricacy to the model architecture, and issues like load balancing and potential underutilization of experts require careful tuning and monitoring. But still, for many applications, particularly large-scale language models where computational resources are at a premium, the improved efficiency and specialized processing capabilities of the mixture of experts architecture make it a compelling option.